Let m and n be positive integers if x square plus mx plus 2n is equal to 0 and this have real roots. Okay, this and this have real roots, then the smallest possible value of m plus n is, okay, if they have real roots, that means your discriminant is either greater than or equal to 0, right? Greater than, or b square minus 4ac is greater than or equal to 0, then the smallest possible value of m plus n is. Okay, let's consider this discriminant here. B is m here, so m square minus 4 into a is 1 and c is 2n should be greater than equal to 0, or m square minus 8n is greater than equal to 0. This is one thing we have got. Okay, we'll think it later on. Okay, this again, b square is 2n, value of b is 2n here, right? 2n square, b square minus 4 into a is 1 and c is m is greater than equal to 0, or 4n square minus 4m is greater than equal to 0, or n square minus m is greater than equal to 0. We'll dividing all by 4. Okay, so okay, perfect. Now what we want is the smallest possible value of m plus n. That means we want smallest possible value of m also and smallest possible value of n as well. Okay, and they are positive integers, so it cannot be 0. They are integers, so minimum possible value is 1, right? Minimum possible. So if I consider this as 1, m as 1, right, this will pretty much satisfied. N square minus or 1 square minus m, that is 1, is equal to 0, pretty much satisfied. But is it satisfying here? No, it is not satisfying here. See, m square is 1, 8 into 1 itself is this, right? So if n is 1, the minimum possible positive integer value of m will be 3. Yes or no? Then only it will be 3 square, right? 3 square. So this, let's say this is 3 square is 9 minus 8, value of n we consider this, so this will give us 1. But is it satisfying here? If n is 1 and this is 3, no, it won't satisfy. Now we cannot go below 3 for m. We cannot go below 3. I hope you're understanding this point, right? So we have to check with n what we can do with it. Okay, n, if I consider it as 2, it will be 2 square, it will be satisfied here, but in that case it will be 16. So 9 minus 16 will not be a positive or equal to 0, right? So in that case, if I consider n as 2, I have to consider m as 4, right? I hope you're understanding this point. So in that case it will be 16 minus 16, pretty much satisfying. And here also n is 2, so 2 square, m is 3, pretty much satisfying here as well. Or m is 4, okay, so pretty much satisfying here, right? Pretty much these are minimum possible value of m and n. M minimum possible is 4, n minimum possible is 2, so the smallest possible value you have to type as 6 in the box. I hope you understood this point. I hope very much interesting question. I hope this is clear, guys.